Next, let us see the movement, the analysis of the shoulder joint. Before going into the kinetics and the kinematics of the shoulder joint, let us see the basic kinematics and kinetics of the shoulder joint. Okay, what is kinetics? What do you mean by kinetics? Kinetics is the branch of biomechanics which deals with the description of forces. Is called the kinetics. And what is kinematics? Kinematics again is a branch of biomechanics which deals with the description of motion. First, let us start with the kinematics. So, as we told earlier, kinematics is a branch of biomechanics which deals with the description of motion. What are the different categories of kinematics? The two main categories of the kinematics are the osteokinematics and arthrokinematics. Osteokinematics and arthrokinematics. From the word meaning, osteo is related to the bone, arthro is related to the joint. So, what is osteo? Osteokinematics is defined as the movement that is taking place in the shaft of the long bones. Again, osteokinematics is defined as the movement that is taking place at the shaft of the long bones is called the osteokinematics. And what is arthrokinematics? Arthrokinematics are the movements that is taking place inside the joint. First, let us see what is an osteokinematics. So, osteokinematics is the movements that is taking place in the shaft of the long bones. Let us see the example. What do you mean by shoulder flexion? What is shoulder flexion? Shoulder flexion is defined, the shoulder flexion of the shoulder. What is flexion of shoulder? Here, the flexion of shoulder is defined as the anterior movement of the shaft of the humerus. Again, flexion can be defined as the anterior movement of the shaft of the humerus. We are not considering any movement that is taking place at the inside the joint. So, when you think about the osteokinematics, what is flexion? Flexion is nothing but the anterior movement of the shaft of the humerus. Okay. And what is extension? What is extension? Extension is posterior movement of the shaft of the humerus. What is abduction? The shaft of the humerus is moving away from the midline. The shaft of adduction is the shaft of the humerus is moving towards the midline, and the medial rotation, the shaft of the humerus is rotating towards the midline, and external rotation is the shaft of the humerus is rotating away from the midline. That is external rotation. So, osteokinematics are movements that is taking place within the shaft of the long bones. And osteokinematic movements are named according to the movement that is taking place at the shaft of the long bones. Okay. Now, let us see the arthrokinematics. What are arthrokinematic movements? Arthrokinematic movements are the movements that is taking place inside the joint. The movement that is taking place inside the joint. And these movements can be classified as the rolling movements, the sliding movements, or the gliding movements, or the spinning movements. Okay. Arthrokinematic movements can be classified as the rolling movements, gliding movements or sliding movements, or the spinning movements. Okay. Now let us see what are the arthrokinematic movements occurring during shoulder movements. Take the example of shoulder flexion. So when you do the shoulder flexion, what is the osteokinematic movement? Osteokinematic movement is the anterior movement of the shaft of the humerus. And what is happening to the head of the humerus? When the humerus is moving anteriorly, what is happening to the head of the humerus? The head of the humerus is rolling posteriorly. The head of the humerus is rolling posteriorly. Okay. The head of the humerus is rolling posteriorly on the glenoid cavity. Okay, so the arthrokinematic movement during flexion of the shoulder is the posterior rolling of the head of the humerus inside the glenoid cavity. To be more specific, when the head of the humerus is rolling posteriorly, there is an anterior sliding of the head of the humerus. There is an anterior sliding. There is a posterior rolling as well as an anterior sliding. That is, there is a the head of the, so this is the glenoid cavity. So this is the head of the humerus. So there is a posterior rolling as well as there is an anterior sliding. There is a posterior rolling and this is the anterior sliding. Posterior rolling and anterior sliding take place. There is a posterior rolling and anterior sliding take place. So when the shoulder goes for flexion, the osteokinematic movement is the anterior movement of the shaft of the humerus, and the arthrokinematic movement is the posterior rolling of and anterior sliding of the head of the humerus. And most of the exam purpose, they will ask only the posterior rolling. Okay, so don't confuse with the anterior sliding. There will be say posterior rolling. Okay, and what is happening during extension? So during extension, the osteokinematic movement is the posterior movement of the humeral shaft, and arthrokinematic movement is the anterior rolling of the head of the humerus. The arthrokinematic movement during extension is the anterior rolling of the head of the humerus. And what is happening during abduction? What is the arthrokinematic movement? During abduction, the arthrokinematic movement is the inferior rolling of the humeral head. And during adduction, this is a superior rolling of the humeral head. And during internal rotation, there is a posterior rolling of the head of the humerus, and during external rotation, there is an anterior rolling of the humeral head. So these are the arthrokinematic movements, and these movements are very, very important when you are going for the manipulation of the or mobilization of the shoulder joint. When you try to do shoulder mobilization, if you give importance only to the osteokinematic movement, the range of motion cannot be achieved. Osteokinematic movement along with the arthrokinematic movement is very, very important in giving proper mobilization technique to the joint. So the basic biomechanics of arthrokinematics is very, very important or very, very helpful in providing mobilization of the joints. So let us see another one important rule, the convex concave rule and concave convex rule. So these rules will give a relationship between the osteokinematics as well as the arthrokinematics. First, let us see what is a concave convex rule. What is a concave convex rule? So a concave convex rule states that when a convex bony component moves on a concave bony component, the convex body component moves in the opposite direction to that of the shaft of the long bone. Take the example of glenohumeral joint movements, glenohumeral shoulder flexion. Okay, again the convex concave rule, I'll explain once again. When a convex body component moves on a concave body component, the convex body component moves in the opposite direction to that of the shaft of the long bone. Okay. So here, take the example of shoulder flexion, which is the convex bony component, the head of the humerus. When the head of the humerus, and which is the concave bony component, the glenoid fossa, the glenoid cavity. So the convex head of the humerus moves on the concave glenoid cavity. Okay, what is the movement? That is the posterior rolling. And what is the movement that is taking place at the shaft of the long bones? Anterior movement. So that is the convex concave rule. So again, the convex concave rule states that when a convex bony component moves on a concave bony component, the convex bony component moves in the opposite direction. That is, the head of the humerus rolls posteriorly while the shaft of the humerus moves anteriorly. That is the convex concave rule. And now let us see the concave convex rule. Okay, so the concave convex rule can be seen at the elbow joint. You can see the concave convex rule at the elbow joint. So either the humero-radial or the humero-ulnar articulation. So let us first analyze the humero-ulnar joint movements during elbow flexion. So what is the humero-ulnar joint? So the ulnar bone has got the trochlear notch. Here you can see the trochlear notch of the ulna. The inside is the trochlear notch, and here you can see the trochlea of the ulna. So the trochlea of the ulna is the convex shape. Trochlea of the ulna is the concave shape, and trochlear notch of the ulna is trochlea of the ulna is convex shape and the trochlea of the ulna is concave shape. So here, what is the rule? Concave convex rule states that when a concave bony component, so this, consider this as the trochlear notch of the ulna. So when the trochlear notch of the ulna moves on the trochlea, convex shaped trochlea of the humerus, what is happening? The concave shape is moving anteriorly. At the same time, the shaft of the ulna is also moving anteriorly during flexion. That is, a concave convex rule states that when a concave bony component moves on a convex bony component, the concave bony component moves in the same direction as that of the shaft of the long bones. The example is when a concave shaped trochlear notch of the ulna moves on the convex shaped trochlea of the humerus, the concave shaped trochlea of the ulna moves anteriorly during flexion. At the same time, the shaft of the ulna also moves anteriorly. Okay, another example, the humero-radial articulation. You can see the concave shaped head of the radius. The concave shaped head of the radius moves on the convex shaped capitulum. Here you can see the capitulum of the humerus. During flexion, the concave shaped head of the humerus moves anteriorly on the convex shaped capitulum of the humerus. At the same time, the shaft of the radius also moves anteriorly. That's about the concave convex rule. So again, the convex rule, when a concave shaped articulating surface moves on a convex shaped articulating surface, the concave shaped articulating surface moves in the same direction as that of the shaft of the long bones. Whereas in a convex concave rule, when a convex bony component moves on a concave bony component, the convex bony component moves in the opposite direction to that of the shaft of the long bones. That's about the convex concave rule and convex concave rule. Next, let us see the plane, axis and plane. What do you mean by plane and axis? So why I'm telling is that all this comes under part of kinematics. What is plane? Plane is nothing but the surface through which the movements take place. Plane is the surface through which the movement take place. And what is axis? Axis is the line which passes perpendicular to the surface through which the movement take place. So in the human body, the movements can be divided into 3 planes and 3 axes. Okay, first let us see the frontal plane movements. What is the frontal plane? Frontal plane is otherwise called as the coronal plane. Frontal or the coronal plane. So the frontal or the coronal plane is the plane which divides the body into a front and a back half. So it's a plane which divides the body into a front and a back half. So the plane is like this. Okay, the plane is the plane which divides the body into a front as well as a back half is called the frontal plane. Okay, so this is the how this plane divides. The plane divides into like this, which divides the body into a front half and a back half. So here you can see the frontal plane, and this plane corresponds to the frontal or the coronal suture of the skull. So the frontal plane or the coronal plane is the plane which divides the body into a front as well as a back half. Okay, it's a front half and the back halves, and this plane corresponds to the frontal suture. This is the frontal or the coronal suture, correspond to the frontal or the coronal suture of the skull. And which is the axis? So if the plane is, if the plane is like this, the axis should be the line which passes perpendicular to the plane. So what is the plane? The axis should be the axis which passes perpendicular to the plane. So what should be the axis? The axis should be an anterior posterior axis. So the axis should be an anterior. So the axis should be a line which is passing like this, anterior posterior axis. Okay, and this axis is also called the sagittal axis. Sagittal axis, because it is correspond to the sagittal suture of the skull. Okay, so, and which are the movements possible? Which all movements are taking place on the frontal plane around an anterior posterior axis? So this is the plane. This is the plane. So which movements are, whether flexion or extension take place? No. When you try to do flexion, you are obstructing this movement. The plane is obstructing the movement. Okay, whether you can do medial rotation, lateral rotation? No. Again, this plane is obstructing the movement. So which movements you can do in the frontal plane? The only movement you can do is the abduction and adduction can occurs in the frontal plane around a anterior posterior axis. The only movement that can be possible is in a frontal plane or a coronal plane is the abduction and adduction. So abduction, adduction occurs in the frontal or the coronal plane around an anterior posterior axis or the sagittal axis. So next we'll come to the second plane. The second plane is the plane which divides the body into a upper and lower halves. The plane which divides the body into a upper and lower halves. The plane which divides in the body into a upper and lower halves. Which is that plane? Is called the transverse plane. The plane which divides the body into upper half and lower half. And that plane is called the transverse plane. So how the axis should be in the transverse plane? The axis should be a vertical or the longitudinal axis. The vertical or the longitudinal axis. Okay, the vertical or longitudinal axis. And which are the movements possible? Whether you can do flexion, can you do flexion? No. Transverse plane flexion is not possible because the plane obstruct the movement. Whether it can do abduction, adduction? No. The only movement that is possible in the transverse plane is medial rotation and lateral rotation. So medial rotation and lateral rotation occurs in a transverse plane, or it is always called, otherwise called as the horizontal plane, transverse plane or the horizontal plane around a vertical axis or longitudinal axis. There is two different names, vertical or longitudinal axis. So medial rotation, lateral rotation take place in a transverse plane or a horizontal plane in a vertical or the longitudinal axis. And which is the third plane? The plane which divides the body into, this is the plane, into a right half and a left half is called the sagittal plane. Is called the sagittal plane, and which correspond to the sagittal suture of the skull, which corresponds to the sagittal suture, where you can see the sagittal suture, the suture which divides the parietal lobes into two halves is called the sagittal suture. This is the sagittal suture. And so the plane will be like this. So if you insert this paper like this downwards, what happened to this skeleton? This skeleton can be divided into two halves. Two halves means a right half as well as a left half. And so the plane will be like this. The plane which divides the body into a right and a left halves is called the left half is called the sagittal plane. And what is the axis? It's the frontal axis, frontal or coronal axis. And imagine which are the movements taking place. Flexion and extension take place in a frontal plane or sagittal plane around a frontal or the coronal axis. So that's about the axis and plane. Okay, so plane is the surface through which movements take place, and axis is the line which passes perpendicular to the plane through which the movements take place. Basically, we have three axes and three planes, and the plane which divides the body into a front and a back halves is called the frontal plane or the coronal plane, which corresponds to the frontal suture of the skull, frontal or the coronal suture. And the axis can be an anterior posterior axis or the sagittal axis. The movements possible are abduction and adduction. The second plane is the plane which divides the body into an upper half, and the lower half is called the transverse planes or the horizontal plane. And the axis is the vertical or the longitudinal axis, and the movements possible are the medial rotation and lateral rotation. And the third plane is the plane which divides the body into right and left halves, and the axis is the frontal or the coronal axis. The frontal plane is the sagittal plane is the frontal or the coronal axis, and the movements possible are flexion and extension. So that's about the movements taking place in various axes and planes. Now let us see the generalized movements. What are the different types of movements? When you generalize the movements, what are the different types of the movements? So movements can be categorized as a translatory motion or a linear motion. What is a translatory motion or a linear motion? So translatory motion or the linear motion is the movement of an object or a segment in a straight line. Linear or the translatory motion is the movement of a segment or an object in a straight line is called the linear or the translatory motion. Okay, for example, if I want to grab an object, so So imagine if I want to grab this bottle. So I am moving my forearm hand segments forward to in order to grab this bottle. So the movement of my forearm and hand segment towards this bottle is an example of a linear or a translatory motion. So linear or translatory motion is nothing but the movement of an object or a segment in a straight line. And the second motion is the rotatory or the angular motion. What is a rotatory or angular motion? Rotatory or angular motion is the movement of an object or a segment in a curved path. Okay, in a curved path is called a rotatory or translatory motion. What is an example? So I am also translatory motion is I am holding this bottle and I am bringing this bottle towards my mouth. Okay, imagine I am drinking this is a bottle of water, so I am bringing this bottle of water towards the mouth. So this is a rotatory motion or the angular motion. So the angular motion or the rotatory motion is the movement of an object or a segment in a curved path. And what is the third motion is curvilinear motion. What do you mean by curvilinear motion? Curvilinear motion is nothing but the combination of both translatory and rotatory motion. It has got both the components of the translatory as well as a rotatory motion is the curvilinear motion. Example, drinking a glass of water. Imagine in drinking a glass of water. It is a curvilinear motion. So in order to drink the water, first you have to move your hand and forearm segment to hold the glass of water. That's a translatory motion. Then bringing the glass of water towards the mouth is a rotatory motion. So curvilinear motion. So in that process of bringing a glass of water, you have both the components of rotatory and translatory motion. So and most of the movement, 90% of the movement activities of your day, activities of daily living is a combination of both rotatory and translatory motion. That is it. Most of the activities of your daily living is comes under curvilinear motion. So that's about kinematics.